Right now, inside your body, atoms are vibrating at 500 trillion times per second. They never rest. They have never rested, not once, since the Big Bang 13.8 billion years ago. But what if just one of them stopped? Not slowed down, not cooled, just froze, dead still. What sounds like nothing would trigger a chain reaction so violent, so fundamentally universe breaking, that physicists say it shouldn't even be possible. And today, you're going to find out why the universe would rather destroy itself than let a single atom sit still. Here's something most people never learn in school. Atoms don't move because they have energy. They move because the universe literally forbids them from stopping. This is called the Heisenberg uncertainty principle. It says you can never know an atom's exact position and exact speed at the same time. If an atom truly stopped, zero velocity, perfectly known, then you'd know everything about it. And quantum mechanics says that's illegal. It's not a technology limit, it's a law woven into the fabric of reality itself. The universe would rather inject random energy into a particle than let it be perfectly still. Even at absolute zero, minus 273 degrees, atoms still jitter. Scientists call this zero-point energy. It's the universe's way of saying, you will never stop moving. So what happens if one atom breaks this rule? The moment an atom hits zero motion, its position becomes infinitely precise. According to quantum mechanics, this means its momentum uncertainty explodes to infinity. Think about what that means. The atom now has an infinite range of possible energies, simultaneously. It's everywhere and nowhere. Here's the mind-blowing part. This would require infinite energy to achieve. More energy than every star, every galaxy, every black hole in the observable universe combined. Stopping one atom is harder than lighting every sun that ever existed at the same time. But let's ignore that. Let's say it happens anyway. An atom with infinite momentum uncertainty doesn't just sit there. It erupts. The energy shock wave would make a supernova look like a birthday candle. We're talking about a burst that rivals the Big Bang itself, from something smaller than a billionth of a meter. But here's what's even crazier. It wouldn't just be an explosion. The laws of thermodynamics would collapse at that point. Entropy, the arrow of time itself, would become meaningless. Cause and effect would break. At that single point in space, time would stop having a direction. And there's another problem. Every atom in the universe is connected through quantum fields. They're not isolated dots. They're ripples in the same ocean. A violation at one point sends shock waves through the entire field. The electromagnetic field, the Higgs field, the strong and weak nuclear fields, all of them would register a disturbance. It would be like plucking one string on a guitar and having every instrument on Earth scream at once. Now here's the fact that will keep you up tonight. The universe has a built-in immune system against exactly this scenario. It's called quantum decoherence, and it works faster than you can imagine. Every particle is constantly being observed by its environment. Photons bouncing off it, other atoms nudging it, fields pushing it. This constant interaction forces particles to stay uncertain, to stay fuzzy, to keep vibrating. The universe doesn't just prefer motion, it actively enforces it, every fraction of a second, on every particle that exists. There are roughly 10 to the power of 80 atoms in the observable universe, and every single one of them is being babysat by reality itself. Scientists at MIT cooled atoms to within a billionth of a degree above absolute zero. The atoms still moved. They formed the state called a Bose-Einstein condensate, where thousands of atoms act as one, and they still couldn't be stopped. Nature always finds a way to sneak motion back in. The universe treats stillness like a virus and eliminates it instantly. So here's what you're really looking at. One atom stopping wouldn't just be a tiny event. It would be a paradox, a contradiction so deep it would threaten the logical structure of reality. And maybe that's the most incredible part. You are made of atoms that have been vibrating since the beginning of time. They vibrated inside dying stars. They vibrated through the vacuum of space for billions of years. And right now, they're vibrating inside you, listening to this, thinking about this. You are the universe in motion. And the universe will never, ever let you stop.